Yeah, I think I'm going to go ahead and get started. So hello, everyone. Welcome to Databricks Data and AI Summit. I'm really grateful that you took the time to come to this talk when the expo hall is fresh and new and open for the first time. It's all very exciting out there, so I appreciate it that you're here with me to listen about data, AI, and interactive experiences with AI. So forward-looking statement, you're going to get to see a lot of these over the course of this conference, I think. It's about informational purposes. I don't represent Databricks, some other stuff. Also a reminder to please complete your surveys. Your feedback has a direct impact on how they curate the event in the future. So you'll receive a survey for attending this session. Give me 5 stars, please. I don't actually know how the review works, but actually put in the honest review, not 5 stars. Looks like there's not a full review like that. In any case, on to the talk. So I'll introduce myself first. My name is Cole Bowden. I'm a software engineer, data engineer, and developer advocate at a company called Firebolt. We're a low-latency cloud data warehouse and query engine. We're going to be talking about the query engine side of things mostly while we're here today. And I'm here to talk to you about the power of using low latency for AI applications and how you can make an AI application an interactive, seamless experience. So, an overview of this presentation. First up, I'm going to overview what RAG is. Hopefully we all know what this is. It's been around for a little while now. It's not a foreign concept. I'm going to discuss using SQL for RAG and using relational SQL databases like something in Databricks as a backing for an AI application that has an interactive user experience. I'm going to discuss the power of low latency, where Firebolt can slot into this picture, and how getting really accelerated low latency queries can make that user experience on an AI application really, really good. And I'm going to demo this and show it in action, as well as open up to Q&A. We're going to figure out the logistics of Q&A in a bit, but we'll get there when we get there. For starters, defining RAG and what it does. More or less, it's AI and data. When you're using generative AI, they're a predictive model that tries to guess what's coming in next. And you can supplement them with any kind of additional information. I think most people in this room have probably done it. If you use ChatGPT and you've uploaded a file to it and said, please read this file, that's RAG. You're retrieving information out of that file and then generating output based off of that. It's not magic. It's pretty simple a lot of the time. But it's a really useful and strategic tool for getting more specific insights related to a domain. It can be more current, it's a model is trained and then it only knows the world up to that point. So if you wanted insights as to events or data that you acquired yesterday or last week, your model won't have awareness of that without using RAG as a strategy. It's controllable. You can kind of tell it to focus in on the exact data you're interested in hearing about, and you can trust it more. You're going to have less hallucinations, you're going to have more accurate insight into your data, and that's a really powerful idea for making sure that your generation is what you want it to be and not just trusting the general non-domain specific world of generative AI. So the question then is, why am I going to suggest using SQL for RAG? I think in the AI space, it's a lot of AI applications want to use vector databases. They want to tap into similarity search and use comparisons to generate this predictive output. I shouldn't have to convince you that SQL is everywhere, given that we're here at Databricks Summit, where everyone's probably either using or looking at using Databricks. You've got relational data all over the place, whether that's in Delta Lake or Unity Catalog or whatever else. So that I think we're on board with here. But SQL also does some things that vector DBs aren't good at. You can do aggregations faster, so if you're trying to do statistical analysis on data, whether you're looking at medians or averages or percentiles, sums, distinct counts of elements, all of that is a lot quicker and more efficient to do with a SQL database. The same is true for time-based analysis with indexing. You can filter on events that happen on a specific date with high reliability, speed, and accuracy, which is really handy. SQL's multifunctional. If you're tapping into your SQL database or like a Delta Lake table, it's multifunctional. You can use Delta Lake for more than just AI. You can use it for everything. You can use Unity for more than just AI. You can use it for everything. And that means that you have a lot of versatility. You're not standing up multiple different databases and different systems, which incurs a higher total cost of ownership. You're going to have pipelines and ETL connecting these things. It's going to take a little more engineering work to support, a normal relational database and also a vector database for AI workloads. And also, traditional relational databases are fully ACID compliant, whereas vector DBs aren't, which means that they can be productionized, you can write to them as part of your business, you don't have to worry about things breaking, exploding, duplication of data, errors during transactions. It's a tried and true technology that just works a little smoother. So SQL has these benefits that make it more reliable, make it simpler, make it less expensive. But the downside, you might think, is, well, SQL's kind of slow sometimes, especially for AI-related applications. And that is where I'm going to bring in Firebolt. So Firebolt brings ultra-low latency SQL to your Databricks tables and to SQL itself. Firebolt is able to connect to tables managed in Unity Catalog and deliver 10 millisecond query latency on those tables. It goes very, very fast. And that powers kind of these seamless, interactive human use cases where if you're asking a question of a model or you're running a query and you get a response back in 10 milliseconds, you hardly even realize that you've done a round trip with a SQL query into your database and back again. And for a user experience or an analyst experience or anyone trying to understand this data and run an AI conversation, that low latency makes sure that this conversation keeps you in tune. If you're asking a question and running a SQL query takes 30 seconds or 45 seconds, it's going to take you out of the conversation. It interrupts your flow. You can't deliver that to users. You can't deliver that to customers. That's just simply not going to be acceptable. And so when you use Firebolt, you get that interactivity of really low latency queries. We have scalability. Firebolt can scale up to handle thousands of queries per second, which means that if you have many users using an AI application, it's not going to be a bottleneck. You can use a relatively inexpensive Firebolt query engine connected to Unity Catalog to handle many concurrent users at the same time, and they'll all get that low latency. And it's also really efficient. By leveraging caching and doing as little work as possible, it's able to save on cost. And these thousands of queries aren't going to be very expensive. They won't run up a massive bill. You're charged for uptime rather than per query, which means that the more users are running similar queries, the more Firebolt will speed up and the less it's going to charge you relative to other solutions. So Firebolt can plug into Unity Catalog. It actually doesn't write to Unity, Delta Lake, or Iceberg. It's read-only on top of these services. So you should still use your Databricks account. You should still use Databricks for managing, for ETL, for writing your data. And then Firebolt, when you need low latency or serving layer on top of this, it'll go very, very fast. So I have a demo to showcase this. I am going to provide a rather transparent caveat that my demo actually is not on Unity Catalog. Firebolt does have its own storage format as well that I'm going to be using for this, not because it's faster, but because I'm using some data that was generously provided to us by one of our customers, and we are not allowed to write that into Databricks, so we didn't get permission to do that, so I will be using data in Firebolt itself rather than Databricks. But I'm going to say if you want to see a demo in action showing off the same latency I'm talking about here today on a Databricks Unity Catalog table, we have our VP of Engineering, Benjamin Wagner, giving a talk tomorrow at this same time in a normal room where he will be showing off how we managed to achieve this low latency and demoing that in action. And that's kind of more generic, it's not AI tailored, but that'll be a really compelling talk if you're curious about how we made this work. So for now, I have to ask you to generously pretend like I'm querying a Unity Catalog table as part of this demo. It would behave exactly the same way. But I'll swing into now an application, and the tech stack for this is just a user interface, and I'm going to be sending a message that's going to do an API call to ChatGPT 4.0 model. That model is connected through a tool called Chainlet. It knows to generate SQL based off of the natural language I provide. With that SQL, it will run that SQL on Firebolt as the backend query engine. Firebolt will return results to my application. My application will provide those results back to 4.0. 4.0 will interpret those results and then generate a response. So this query is, when I send a message, it's going to go from my laptop over the Wi-Fi to 4.0, from 4.0 back to my laptop, from my laptop to Firebolt, from Firebolt back to my laptop again, and then from my laptop to 4.0. We have a lot of network jumps in here, and hopefully the conference Wi-Fi is not going to make this very slow. But I can ask what data is available, and then we'll see this data set provided to us by one of our customers. This is web traffic data from a single day in August of 2024, so last fall. You see that this is about 7 terabytes of data. This is not a toy data set. This is a real amount of data that we're looking at here. It's a pretty large table with a lot of different information about people who are using search engines and then click data and add data as well. So we can ask a simple question of this data set, like what were the top 10 search engines? And perhaps unsurprisingly, once we generate our result, the Wi-Fi is being slow, but there we go. You can see the top search engine in the world is Google. That hopefully is expected. And it's lapping all of the other search engines in the world. You can see as we go down this list, we're looking at a bunch of different search engines, being, of course, it's Microsoft's competitor, Yandex, popular in Russia, Yahoo Japan, I think you can guess where that's popular, DuckDuckGo for those who are privacy aware. I believe Naver is popular in South Korea. So you see like kind of these global search engines popping up here. And the cool thing about this demo is I can actually go look at the query that I ran to get this information. So you can see I was selecting my search engine, my count, this usage count, from this table, grouping by search engines. You can see that this query read, that's kilobytes, megabytes, gigabytes in 0.2 seconds and return these results back, and then ChatGPT generated a message on them. But we can get more specific and we can do some more exploratory analysis on this data. And we can ask, for example, what were the top 10 keywords that drove traffic to Airbnb.com? And it's going to run another query. And we're going to see clicks given to Airbnb based on what people are searching. Once again, we can go look at the query that was run. You see it took 0.08 seconds this time, so the latency in this stack was mostly conference Wi-Fi. If you're in a quick office with speedier Wi-Fi or on an Ethernet connection, or even running an application in the cloud, then that Wi-Fi latency goes down, and this starts to become very, very, very quick. And Firebolt makes sure that it stays that quick. But you can see here, people are searching a variety of different terms to get to Airbnb. You can see Airbnb is, of course, the most common. That's not a surprise as well. Sometimes people put a space in there. Sometimes people search Airbnb, which is a little interesting to me because I don't know what that is. Verbo, one of their competitors, is also high up on that list. We'll explore that a little more. And then you see some various less popular results. This one, probably an artifact of the data set being from a single day. I'm not sure what went on there, maybe some bot activity. But in any case, we can drill deeper into this. First of all, maybe we want to use the power of AI to just ask a simple question like, what is Airbnb? Is that a music genre or what? And you all might have your guess, but the joy of AI is that though this is a SQL-backed RAG application, I don't have to use my data for everything. I can just use the model to give me some insight as to understanding my data set. It's not always running SQL. And here it's going to say, yeah, it's like a misspelling or informal abbreviation. I'm not sure who's doing this, but the model seems to think that's the most likely culprit here, and I'll buy it. I don't know what else I would think. We can also continue to do some analysis. It's people searching Verbo and clicking on Airbnb is a little interesting. I personally, if I search Verbo, I'm probably clicking on the Verbo website. So what's causing that to happen? And we can drill into this data a little more by asking questions like organic traffic. So an organic click is when you search for something and you just click on it in the normal search engine results. Inorganic traffic is if you've ever searched something on Google and you've seen promoted or ads in the top 3 searches. I'm sure we're all used to this every time we search for a data product, and some competitor's data product pops up as the search result, as a first result from an ad. And we can ask, what percentage of traffic for each of those keywords was organic? And when I run this, we're going to run another query, and it's going to give me a breakdown on all of these keywords. And what you can see here is, interestingly, they're running ads on their own name. Airbnb wants to make sure that when people search for them, that's what they're clicking on. But even more than that, they're running a ton of ads on the Verbo keyword. When people Google Verbo, it's some percentage of the time they're going to click on Airbnb, and almost all of the time that happens, it's because Airbnb is running advertisements on the Verbo keyword. They want to steal their competitors' traffic. This is a real data set. This is proof. If you ever wanted to do some competitive intelligence in the home sharing market, you now know that Airbnb is advertising on the Verbo keyword. That's real. And perhaps unsurprising again, because it's kind of their business to do that. And again, I want to reiterate, this query ran in 140 milliseconds. The human blink of an eye is 150 milliseconds. So we're able to power this kind of interactive chat conversation by running really, really, really fast SQL in a way where accessing your data is basically not providing any slowdown whatsoever. And this scales again to many, many, many users. And this is the power of Firebolt on top of your relational data and how it can power interactive applications. So I'd like to thank you all for coming to my talk. I will be in the Firebolt booth. It's like right over there for the rest of the entire conference. So if you'd like to talk more in person, please feel free to swing by. And again, I'd like to remind you to please also go to Benjamin Wagner's talk tomorrow on how Firebolt got this low latency on Iceberg and Unity. It is a super cool talk. I'm really excited for it, and I'd really encourage going there because you're going to learn a lot about how he engineered this. Thank you, everyone.